All right, let's have you guys to first take a look at um these two sets of definition of a trig functions. Now the lower portion is something that you already know very well, hopefully, right? Since the test is in 2 days, right? And the top portion will be something we're gonna go over in a few minutes. And what you can do is just compare them. One has a unit circle, right? By the way, unit circle is just a circle of a radius 1. This is what you used to know, right? Just go ahead and compare how those functions are defined, right? To see if they have something common between these two, sets of definitions, and also find out maybe the major difference. All right. Oh, oh yeah. I guess that this class we have 12 people. All of you guys have the access to Pearson, which is good because I do have a few students who haven't got the access back. Now, again, just to remind you, the test covers from 5.1 to 5.4, but there will be a homework 5.5, right? That's going to be due, I think, on the 6th, right? February 6th, midnight. So please make sure that you don't miss the deadline. Now, the quiz is due on the 5th. So you're not in a rush, because you only have like a day or two before the test. So it's better for you to focus on the test review, but maybe have a plan or book a slot. Then once you're done with the test, come by and get your quiz done. All right, cool. Now, all right, so just want to know where you guys are in the test review. For the X, Y, R definitions for the sine for the trig functions, how many of you are able to memorize them at this point? Use whatever tricks might be drawing the right triangle. Okay, if you're getting there, great. Or if you're already done, that's even better, right? But if you haven't, I mean, you should seriously think about start doing it later today. Definitely tomorrow, because when we come back tomorrow, we'll go over some remaining questions in the test review packet if we haven't got to, especially the word problems. Then there'll be some facts I do have to tell you for the 5.4, which doesn't seem to appear on the test review packet, but I do have to give you a few examples to make sure that just in case we get a question like that, what do we do? Because there are only 3 questions for 5.4, right? And now I'll show you all 3 in a few minutes. Like I said, just to be safe. Now, I haven't received the finalized version of the test. So I'm not sure how many questions will be there, but the work has to be reasonable, right? But I'm sure that there will be word problems, FRQs. As soon as I heard anything, so I'll let you know. Hopefully, tomorrow, right? But like I said, at this point, so I can understand that since there's a lot of things that you better remember. On my end, I don't see any serious issue for you guys understanding what's going on, right? Understanding all those concepts, right? There's no formulas that you don't understand. or you just find it so awkward that you don't want to accept. But the problem is, it's just that you will be much better off to have a cheat sheet, but you're not allowed to have that, right? So now you figure it out, right? Yeah. Anyway, oh, full function calculator, please. I mean, it is optional for you to bring a full function calculator, but if you don't, then you end up working everything out by hand, right? But like I said, there will be word problems, and hopefully it won't be a lot. Well, there won't, a lot of word problems anyway in a review packet, right? Yeah, yes. Yeah, that's fine. So basically, if you don't see those trig function buttons on it, that means you're fine. Right. Cool. Now, let's get started. So let's say if you're okay with always starting from a right triangle in the first quadrant, and you see that P is located at x comma y, and the distance from the P to the origin is r, right? I'm projecting. Yeah, okay. Using SOHCAHTOA, let me put this down. To set things up using x, y, r, right, for all 6 functions. If you could do that, that's great. But now let's say, what if we want to standardize the whole process? Because we realize there's an issue here. What if I fix this angle to be whatever your angle you want? Let's say make a easy angle. Let's say 60 degrees. Okay, then I go to 60. Will that distance r matter to the value of all 6 functions if the angle has been fixed at 60? Some say yes, because you have the r right there, right? If you have a distance r to be 1 unit, 100 unit, right, it will make a difference. But what do we call those guys? They are called trig functions, right? What do you think a function is going to do in general? The theta, which is the angle, that's input to a function, right? It will give you an output. And a function has to be definite about its output, right? If you give it an angle, right, it's going to tell you, hey, let's say for sine 60. Now, anyone happen to know what sine 60 is? 60 is pi over 3, right, radians. But sine of 60 is radical 3 over 2. Well, you guys are lucky that the test is on Wednesday. Because this is something you just have to remember. And the way you remember this, draw the right triangle, right? But like I said, you could do that. That's why, you probably couldn't really do it right away, because you can, draw the triangle right away, right? Anyway, but 1, 2, radical 3. Anyway, but do you see that this function depends on the angle? If you fix the angle to be 60, it doesn't matter where you pick the point P, right? It could be 1 unit, 10 unit, 100 units. The angle is going to be the same angle, and whatever output you get from the sine of this angle, or whatever function you get, right, for the same angle, it's going to be the same. And that's why they're called functions. Okay? And also, this is how the ratio works. So let me tell you something about the ratio, so that you can see that sometimes it's not about the absolute amount that you're playing with, right? It is actually the ratio that matters. So what happens if you guys are comparing if Publix or Target might pay you guys better, right, when it comes to like an hourly rate, right, the part-time job, I guess that they're probably similar. But just so you know, maybe sometimes you're talking to a friend, I worked for 10 hours, well, let's say 8 hours, right, for Publix, and I get paid for, $100, right? And another person said, well, I got paid for $150. Oh, you get a good job? Maybe, they pay you more? Does it really work that way? $150 just because the guy got paid, more than you did? No, you can ask for, how long have you worked? You worked the whole weekend to get $150? I only worked for 8 hours. So it's not the absolute amount of money, right? You have to find, the amount of money, right, divided by the hour, you get the rate, right? And that's what matters. Now, what about these guys? Those are ratios. That's why if you have a super large R, the corresponding Y is going to be bigger. Find a ratio, you get the same thing. That means it seems that the theta depends on the R, but don't get me wrong, you're trying to get the Y and R to figure out what this ratio is. Once you get it, it has nothing to do with the R. It's divided out, right? So your hourly rate for Publix doesn't depend on how long you work. It depends on your rank, right? Just really work for like 100 days in a row, that gets you on top of the rank of the pay, right? It doesn't work that way. Now, if the R doesn't really matter, as long as you can figure it out where the point P is by picking the R, getting the corresponding X and Y, you're going to find out all those ratios, right? And find out all those trig functions. Then why would you get yourself some trouble getting some weird R's? Have you ever recalled that there's some R's from the problems? There could be radical 13, right? Because you have those weird number X and Y's, right? So they say, make your life a little bit easier. Let's pick all those points, right? The point P on a unit circle. A unit circle is a circle of a radius to be 1 unit. That means whichever point you're looking at on the circle, the distance from that point to the origin is guaranteed to be 1 because we define it that way. So that's going to ease up the whole process because you don't have to get the R anymore. R is guaranteed to be 1 if you were to adopt the unit circle definition. And this is why if you were to get y over r for the sine function, do you see that r is not there anymore? Because r is 1. So who put the 1 there, right? Now check this out. Cosine is supposed to be x over r, but if r is 1, it's just about x, right? Now, what's even better is think about the cosecant, which is the reciprocal of the sine, right? So you typically flip, right, to get r over y, but r is 1. That's why they put the 1 there to hold the place. R is gone, not because it becomes 0. It becomes 1, okay? And so make sure that you don't memorize the new set of definition using unit circle as if it's a complete new set. They're the same. This is even better, right? It's just a very special choice of an R, right? So hopefully, if you see that, I have a cheat sheet of all 4 pages, right? But, I just try to put everything that you better know on it so that, if you see a problem that requires something else that isn't put on a cheat sheet, then, that's on me. But yeah, if you use the unit circle, then you had R, to be 1. You don't even have to calculate it anymore because it's just 1. Right? And let's take a look at those questions in the test review packet, and they will be very clear. If they want you to recall the definition, they have to tell you, are you going with the unit circle or are you going with, the XYR version? All right, let's take a look. All right, and those are the only questions left over in the second packet. All right, so now do you see that? given the point on the unit circle. So you need to adopt that unit circle definition, right? R is guaranteed to be 1. Find out those trig functions. Oh, by the way, so if you're wondering why they start to use the t instead of theta all of a sudden, you might laugh at, why they do that. Well, at least that's what I guess. The theta spells a ETA, right? So it starts with a T. And they try not to show you the theta so that you're always crazy about angles. Because what we're going to have to do after a few minutes is we'll tell you that, hey, this angle T is all real numbers, right? But anyway, so here, think about T is just a weird way to put the angle. Anyway, so now let's take a look at, let's say 24, because, when it comes to secant and cosecant, these are always a bit non-intuitive. Now for unit circle, oh, you know what? I think that what we're always going to do is, I suggest you do that. So as soon as you get the spreadsheet, right, draw a whole bunch of things, right? Maybe the special triangles, right? But for the definition of all 6 functions, I'll draw a right triangle, right, with a point P, right, at the vertex. The hypotenuse R, right, the opposite is Y, the adjacent is X. So then you have sine, right, cosine, and tangent. And the reciprocals, right, cosecant, secant, and a cotangent. SOHCAHTOA, right, sine is opposite of a hypotenuse, will be Y over R. Cosine is adjacent of a hypotenuse, X over R. Tangent is opposite of adjacent, so Y over X. And you flipping them, right, to get reciprocals, R over Y for cosecant. Oops, yeah. All right, secant is going to be R over X, right? Cotangent is going to be X over Y. All right, but now in 24, so we need a unit circle, which means that R is going to be 1, right? And secant is supposed to be R over X, but since R is 1, so it's nothing but 1 over X. Okay. And what is X? They told you that the point is located at radical 21 over 5, right? That's for the X. So you're going to take the reciprocal. So it'll be 5 over radical 21, right? And rationalize the denominator. You get 5 radical 21 over 21, right? There you go. So the work is actually minimal, right? As long as you know the definition, it's just by plugging, the data they get you. The only algebra you have to do is the rationalization. So what you tell me, do you need a calculator for something like that? No, right? Because they'll waste your time, right? But like I said, for some word problems, you might need the calculator. Okay. Now, why don't you guys try 25? And I'm sure that it will take you almost no time, but let's still make it realistic. So I'll get you maybe 30 seconds, right? So you tell me what you're going to pick, as a whole class, right, in 30 seconds. All right, so that's about it. All right, so if you have an answer, if you couldn't, that's fine. But if you have an answer, raise your hand to let me know what you're gonna pick. Okay, good. All right. Anyone else? Good. All right. Yes, letter B. Well, of course, I already have the definition right there, right? So that means you need to get yourself these things, right? However you can. But once you have it, it's not a big deal. Now, one more thing, just in case you're trying to function, maybe at a higher level, if you have time, right, in a test. Now, sometimes, those numbers, right, and it's fairly possible that people messed up, with the definition, right, or somehow the algebra didn't work out. The student's thinking about picking a D. But as a student, there's no way for the student to tell right away, is D reasonable, right? Because the thing is, if the student see that D doesn't seem right, then, he wouldn't even pick the D in the first place, right? But if you're able to just think for, a few more seconds, as you're going through the options, you see that there's some negative options, right? I mean, ask yourself, how is that possible that cotangent is even negative? Find yourself a good reason where you want to go with a positive or negative. And you remember that the quadrant conclusion about the sines, right? A smart trig class, right? A point with a negative x and a positive y must be in which quadrant? Quadrant 2, right? Now, should a cotangent be positive or negative in quadrant 2? A smart trig class. That means it is only going to be positive in the third quadrant. Second quadrant, cotangent has to be negative. Don't even think about getting a positive answer. And that's why you should be alerted that if there are negative or positive options, there might be a way for you to just quickly get your, help you to identify maybe you have some small error. Anyway, I'm saying that, you don't have to do it, but if you could ever think about doing that in a practice later today or tomorrow, that will be even better. Now, let me go back to this page, since I'm sharing my screen, but I have to go to the textbook. That's why if you see this part of the recording, you might see me talking, right? But the page will be always this part, right? Because this is pretty much what we have to know. And in the next maybe 20 something minutes, bear with me because I do have to tell you a lot of facts, which will make sense, trust me. And also the good news is there weren't any questions so far on our review packet that's asking you guys to reflect on those facts. But that's still part of the 5.4, and they can all be coming from the definition of the unit circles, right? But let's see how that works out. All right. Okay, so now we're here. The first concept that we have to remind ourselves, and now it's applying to the trig functions. So that is the so-called domain and the range. Do you guys still remember what they are? Like, you have to explain to me what's the meaning of domain. What would you say, Max?
Basically, what x could be.
Yeah, that's pretty much it, right? So when he said x, it's the input, right? So the function is like your calculator. You're typing something as an input, it's spit out as an output, right? So domain is whatever numbers you're allowed to type in for a function. You're allowed to put into a function. You might say, well, it can be any numbers, right? But sometimes functions might complain if you put in some numbers that it doesn't like. Let's say a function could be radical x. And if you try to feed -1 to the function, it complains, right? So that's why you better tell people, if you're the one who decided to use this function or invented this function, tell the people there's some numbers they better not to put into the function, right? Or what are the good numbers? And a set of the good numbers that you're allowed to put into the function is called the domain. Now, range is just a set of numbers that you're probably going to get from the functions, right? Anyway, Now let's take a look at again the unit circle definition of the sine and cosine. But let's start with the sine. Since the sine is the same as the vertical coordinate of the point P, that's on the unit circle, right? So don't you think that as you turn the terminal side to vary the value of the y, right, as the P goes along the circle, what are the possible values of the y? Can it go ever beyond 1 if the circle has a radius 1? No, right? It has to stay on circle, right? Can it go even lower than -1? Let me scroll down a little bit. No way, right? But can the y be something like 1/2? Can the point P be somewhere that its vertical coordinate is going to be 1/2? Yeah, right? I guess it will be somewhere here, right? Or -1/2? Do you see that as you go around and around, the y values, which is the value of the sine, can go anywhere in between -1 and a 1, including -1 and 1, but nothing else. All right, so it's not going to go beyond 1 or less than -1. That is the range of the sine, because that's the all possible outputs of the sine function. Because you can never get any number that's greater than 1 or -1 to be the value of the sine, right? So if anyone tells you, oh, I have an angle, whatever that angle is, right? Feed it to the sine function, you get 1.2. It's never going to happen. All right? And that's why we say the range of sine is, let's see if they have it somewhere. It's right there. Do you guys see that? This is the interval notation, right? Or something like that. All right. So the range of the sine function is -1 to 1, right? Inclusive. What about cosine? Now, cosine is defined by the x coordinate of the point P. Now, you can imagine that the P is going to go around the circle, right? What will be the possible values of the x of the point P? Can it go even greater than +1? Can it go even less than -1? No, right? Because it's symmetric. Turns out that the y can go between -1 and 1. The x can go between 1 and 1, -1 and 1, right? That means the cosine has the same exact range as the sine function. Yes, Alani? Sine and cosine, if they always have the same range, yes. But you have to have the same exact independent variable. You know that if you get to, say, 2t here, right, t over 2, you have to transform the functions, things get different, right? But if we talk about the standard form, then you're right. Now, here's a trivial, but it might be a little bit trickier for you to think about in the first place. How would you understand that they claim for both the sine and cosine functions, the domain is all real numbers? It means if you're thinking about what numbers you're allowed to put in for the t, which by the way is the angle, right? It could be any real numbers, right? No exception. Whatever you put it in, -1,000, right? Positive 10 million. Sine and cosine will never complain. It will always give you an output. Here's a way to see it, right? The angle T is made by turning the terminal side, right? Either turning it to the counterclockwise direction, so you're getting more and more positive angles, right? You can keep turning around and around to get even greater angles, right? Say, how would you get an angle of 10,000 radians? Well, just keep turning, right, until you get there, right? You're always going to be able to get that. Now, what if you want negative 10,000 radians? Just turn the other way, right? And keep turning until you get to negative. Negative just, means you go the other way. So now, am I right that I can always turn the terminal side however I want to get all real numbers to be an angle, right? And therefore, t takes all real numbers, and therefore the domain for sine and cosine is all real numbers. And remember, there are 6 functions, right? And sine and cosine are the best 2 functions, since they never complain about any input, and they gives you a very controlled output. The reason I said control is always going to be in between -1 and 1. You're never going to get any crazy things about from the sine and cosine. All right. So domain for sine and cosine are all real numbers. The range of sine and cosine are -1 to 1 inclusive. That's the kind of fact that you may want to know, right? Even if you don't see any questions so far in the review packet. But I'll get you some maybe tomorrow. All right. Any questions so far? You good? Maybe now I can tell from the first 2 periods that since I'm talking about functions, right, domains and range, those are kind of more abstract concepts. So I can tell that people are having a hard time, trying to remember what they did back in college algebra. That's okay, if things get a bit shaky. As long as you can understand what I'm just saying, you'll be fine. Now, what about even odd functions? Somehow they're probably even worse than domains and range, right? They're just pure concepts, and functions are even or not. Maybe you tend to confuse them with even odd numbers. And also don't forget that not every function has to be even or odd. Now, just remind yourself how to tell whether a function is even or odd, right? And right there, that's the definition. Right? Now, just to remind you, say I have a function f of x, which is x squared. I want to see that, hey, what if I put in a variable, then I change the sign of it, right? And see what happens if the independent variable becomes its opposite value. Right? See how the function is going to react. We can try that with, let's say, x is +1. So you have 1 squared, which is still 1, right? And you want to see what happens if I take the opposite of 1. Since you're squaring the -1, it's still going to get 1, right? So now, this function is kind of special. It doesn't care about the positive or negative of a number. It's always going to treat it as a positive, right? So flipping the sign of the independent variable does not change the function value, and that's even. So even function. Now, odd function, let's call it g of x, and it could be x to the third. You do the same thing. G of 1 is 1 to the third, right? Which is still 1. What about g of -1? So now you're taking the third power of -1. You have to get -1, right? So just by flipping the sign of the independent variable, the function value turns into its opposite. If that happens, in general, you get an odd function. And it turns out sine and cosines has a even and odd property. And in particular, cosine function is even, sine function is odd. But there's a way to understand it. Let's first take a look at the cosine function. Here I have a point P, right, that helped me to locate the terminal side of an angle T. Okay, just again, think about that here. The angle is T. What if I decide to make the t negative t, like make it opposite? So instead of turning it all the way here, right, I'll do the other way around, as if that I'm reflecting the terminal side, right? So the P is going to go to the point Q, right? But the Q and the P are symmetric about the x-axis. But this is negative t. Oh, it's just, you know what? Let me make this a little bit thinner. This is positive t. Right? This is negative t. Now, if you could remind yourself how the cosine is defined in terms of the unit circle. In XYR, cosine is adjacent, right, the horizontal side, over the hypotenuse, so x over r. But since there's no r anymore, right, r is always 1 in the unit circle, so the cosine is only x, right? But do you see that as you reflect the point P to make the angle negative, you get to the point Q, but those 2 points have the same x. Therefore, cosine doesn't really care about whether you have an angle or it's opposite. It's always going to get you the same value, right? Regardless, positive or negative. Therefore, you know, cosine is even, right? Now, what about sine? Now, again, imagine that the sine is opposite, which is y, right, over the hypotenuse. Now, r is 1, so sine is basically y, but the y does have to become its opposite, yeah, as you go from P to Q. Just by flipping the sign of the t, make the angle become its opposite, P going to Q, yes, the P and Q does have the same x, but their y's are opposite. And therefore, the sign is going to have a negative sign, right, if you simply flip the angle, right, to be its negative angle. All right. Now, quickly check if you now can appreciate the even odd property of sine and cosine functions. Oops. Start with the odd function. Do you guys remember sine 30? Okay, so well, you can look it up, you know, if you do have it right in your fingertips. Okay, some say 1/2, 1/2, 1/2, 1/2, right? 0.5. Yeah, good. Yeah, that's you guys better start to memorize these things. Now, what about sine of negative 30? Sine is odd. If you make the angle opposite, and the function value will be opposite as well. So that's as simple as that, right? Now, cosine, anyone remember what is cosine 60 degrees? Okay, how come it's happen to be the same as the sine 30? Cosine 60, sine 30, sine and cosine are co-function of each other, right? And therefore, angles added to be 90, that means, okay, there are 2 ways of grouping the functions. You either go by function or co-functions. So sine and a cosine or co-function, right? Secant and cosecant, tangent and cotangent. That's one way to group them, right? Now, unfortunately, you can group them into functions and their reciprocals. Now, co-functions are not reciprocal of each other, except, I know you hate that, except tangent and cotangent, right? There's an exception. So sine and, not cosine, but cosecant are reciprocal of each other, right? Cosine and secant are reciprocal of each other. Unfortunately, tangent and cotangent are co-function. They're also reciprocal of each other, right? So there are 2 ways. I know that sometimes it gets confusing, but here we're looking at co-function identities, right? So now, cosine of negative 60, you guys tell me, what is that? Cosine is even. So it gives no respect to the negative angle, right? It will just be 1/2. And that's how easy it is if you know functions are even or odd, right? Any more identities in the test? No. I I know it's harsh, right? Because you guys even have the reference sheet for SAT, but you know. Anani, I have a cheat sheet posted on D2L. You know, you can. Oh, you have it? Okay. The ones I use is co-function identity. No. I'm sorry, I didn't make the rule. Well, you know the. Oh yeah, technically they are managers. They are managers. Well, hey, uh, I learned it when, you know, we're not even allowed to use calculators. So now the thing is, how many of you want to be a teacher? Now the thing is, you do know that here. Well, it's recorded. I mean, but you guys aren't get to see that, right? You know, I hope that you're not telling me that I don't want to be a teacher because, you know, the pay is so bad, right? But the reality is, yes, right? So money-wise, you guys going to be way much better than I am in 10, 20 years, right? Well, assuming that, you know, if you're going to be an engineer, you know, in next 5, 10 years, that I might be able to catch up with you guys, right? But you guys going to be an engineer maybe in 4 years, right? The thing is, if that's why I actually used to tell my students last semester. Can you imagine those kids at Harvard even sleep less and they work even harder? People have insane IQ are working even harder than we are. That scares me. So now, if you want to be better than I am, you better, like I said, that pay-wise, you need to be like that. Then if I can do it, you can do it. So no, the thing is, guys, the reason why I remember that is because I've been doing it for more than 20 years. That's why if you do it, you'll be way much better than the instructors. I guess I didn't make it better. Anyway, guys, listen. Now, let's say if you do know sine is odd, cosine is even. Does it make sense that the reciprocal of cosine is also even? The reciprocal of sine is also even, right? But the hard part is, how do I see that the tangent is odd? So how do we define a tangent? Or how do we relate the tangent to sine and cosine? Tangent is sine over cosine, right? Think about this. If you were to make the angle opposite, does the cosine care about that? No, it's always going to be the same, right? It is the sine that's going to change into the opposite. Remember that, right? So let's say if I make the angle instead of 30, make it negative 30, cosine doesn't care, right? You're going to get the same thing as before. But it is the sine that says, oh, I'm going to change to the negative. Don't you think that tangent is going to inherit that property from sine? Because the cosine stayed the same. And that's why if sine is odd, tangent is odd. Right? It's like you have a whole bunch of people that, you know, there's one guy is super odd that, you know, make the whole group kind of odd. Anyway. Well, wait until I tell you how I remember sine and cosine being even odd. Because now the question is, unless you want to have that on the cheat sheet, right, and memorizing them, but I mean, your brain will be like, you know, overwhelmed. You have to memorize that many things, right? To make sure that, you know, you're understanding it, right, instead of randomly memorizing stuff. But the way I used to do, not anymore because I'm just so used to that. I know that, but like I said, you know, it's only a matter of time, right? Uh, hey, I have to do this for a living, and I've been doing it for 20 years. And I like it not because I want it, because I had no choice. So think about this. After the trig, you probably don't have to do it anymore. Right? You out of here, once you ace the class, you're done. I still have to do this. That's a good question. So I can be very honest with you. I've never used secant, cosecant, and cotangent in my research career. But ask Professor D, because he was an engineer, and engineers do use that. If you're a STEM route, if you be a scientist, well, let's say if you be a doctor, I don't think you're going to do that. But the thing is, you're going to have to take MCAT, right? They have physics in it. That's a good question, but that's, they decide, you have to be good at everything, right? To be a doctor. I mean, you would trust your doctor better if they know a lot of things, right? Yeah. So, and also, hey, think about this, would you trust the car built by the engineer who doesn't know the trick? You're driving it. You're driving it. Oh, you guys know, is it FIU or FAU? When they built a bridge, it collapsed. They kill people, if they suck at math. The conversion, unit conversion, I always say that all the time. Unit conversion, you go to a doctor, and somebody they give you, a few ounces for the prescription. They give you a couple grams. That's different, right? You take your kids there, right? You're driving a car, they design, right? You're walking on a bridge, they design. So as an engineer or scientist, you can't afford making any kind of mistakes, or you can't afford not knowing stuff. But like you said, if you just don't get you to the career, you just do it for the exams, right? To get you then, right? But still, if you want to be like a top tier, then there's no question why that you don't, why you don't have to know this, right? Anyway, now, the way you can memorize sine is odd, cosine is even. What I used to do. So I'm thinking about sine is like single. Hey, wait, not the kind of single you guys thinking about. So number one. Single means one, right? One is odd number, right? What are you thinking about? All right, so cosine, I see, it's a plural form, right? It's like a couple. What will be a number that you think about like a couple? At least has to be two, right? That's why two is even, right? I know you're thinking about a couple of single, but what if it works out, it works out. It doesn't have to be exactly the way I tell you, right? But you do something to help yourself remember that sine is odd, cosine is even, right? Bear me for one more conclusion, that is periodical. Oh, but let's make it even better, right? They even n in it. Right, say it again. Yeah, go ahead. All right. So calm down and think about what it means. Let's say n could be 0, could be 1, could be -1, could be 2 and -2. What do you think they're doing? Are they just simply adding or subtracting multiple 2 pi to an angle? That's just coterminal angles, right? Coterminal angles are all the same. It means you'll be better off to just go with the t instead of adding and subtracting that many pi's, right? In case you run into some huge angles, right? So let's say, hey, 720 degree is equivalent to 0 degree, because it's 2 times 360, right? Do you see that? So now let's say 390 degree is equivalent to 30 degree. Because if you just take away, 360, right? So if you run into some super big angle or negative angles, just by adding, subtracting multiple of 2 pi or multiple of 360, you're going to get to a much easier angle. And they're all the same. So you're protected, right? You don't have to go with those crazy angles. Just go all the way around to, anywhere in between 0 and 360. So that's what they're trying to do. But they make it fancy. They call it periodic behavior. Periodic is like you go around and come back to the same point, right? So like a year, right? You go around and you're back to the January, right? It's a periodic. Cosine has the same thing, but here's the tricky part. And that's a good question. And that's why I said, hey, care more about the sine and cosine. Because you will see back, in 5.5, that whatever you need to know about tangent, cotangent, secant, cosecant, they all come from the sine and cosine. And you know how nice the sine and cosines are when it comes to a function. They take all real numbers. They never complain, right? Like you guys always complain, but they never complain. But it's okay, you complain in a reasonable way, because to be honest, I was not a big fan of not using calculator, not using scientific calculator. I was a scientist. I would have used the scientific calculator, right? I don't want to do the calculation. But now the tangent is weird because it was defined through the sine and cosine. So we don't have the time to go into the detail of why the tangent behaved a bit odd, a bit weird. But don't get me wrong. If you add a multiple of 2 pi or subtract multiple of 2 pi to the angle and you still evaluate a tangent, it will still be the same. Because coterminal angles are the same and it works out for any kind of functions. But it just so happens that tangent can do even better. It says that I don't want to wait for a whole circle. Like you turn a whole round, right? It said that, I'll be even the same as before by taking a half turn. Half turn is 180 degree or pi radians. So is that good or bad? It's up to you, to decide. But it's just the special thing of tangent. All right. But like I said, if you do a full turn, 360, either one or the other, tangent is going to be the same no matter what. It's just that tangent can even be the same if you just take a half turn. Right. And again, n could be anything. Like I said, hey. The worst case scenario is you get 1 or 2 problems that ask you for the basics of domain and range of functions, right? Let's say the periodic property or even odd properties, right? But you haven't seen them on a real packet. It means it's not very likely. But it is my duty to show you a couple more problems tomorrow, just in case you have a question like that, right? But if I were you, I'll definitely start, hopefully, 5.4, and just take a look at some of the homework problems involving the things that I talked about in the past like 20 minutes, see how it goes, right? Like I said, that of course, you should focus on the things that they do have questions in the real packet, right? Anyway,